In the mid-1990s, Mercedes-Benz was one of the most powerful engineering institutions on Earth. They had money, rules, and reputation firmly on their side. Yet, deep inside their own racing program, a single engineer uncovered a solution that worked too well. It followed the rulebook precisely, but violated something far more important: corporate comfort. The fix didn't rely on brute force, massive budgets, or official approval. It relied on interpretation. What followed wasn't a victory lap, but silence, destruction, and denial. This is the story of how being technically right became professionally unforgivable. The Silver Ghost's defiance. Picture the Adenauer Forst section of the Nürburgring in the spring of 1994. A silver Mercedes-Benz C-Class prototype approaches the chicane. This is a sequence of turns designed to unsettle a chassis, throwing the weight of the car violently from left to right. As the driver attacks the curb, the front inside wheel lifts several inches into the air. In a conventional race car, this kind of lateral load would force the body to roll heavily onto the outside tires, compressing the suspension until the frame nearly scrapes the asphalt. But this car does not roll. The body remains unnervingly flat, parallel to the tarmac, as if an invisible hand is holding it level, while the suspension does all the work underneath. This machine was the Silver Ghost, a fleeting experiment that defied the laws of suspension dynamics and terrified the engineers at Mercedes-Benz. To understand why this car existed, you have to look at the regulatory crisis that was strangling the German Touring Car Championship, or DTM, in the early 90s. The 1994 season was supposed to be the golden era of the Class 1 touring car regulations. These rules were a playground for engineers, allowing for exotic materials, high-revving engines, and sophisticated electronics that rivaled Formula One. But the governing body, the DMSB, had one major concern. They were terrified of the escalating cornering speeds generated by ground effect aerodynamics. To curb this, they introduced a rule that became the defining struggle of the season. They mandated a strict static ride height of 50 millimeters. 50 millimeters might sound like a negligible gap to a road car driver, but in the world of racing aerodynamics, it is an abyss. The relationship between a car's distance from the ground and the downforce it generates is not linear. It follows an inverse square law. The formula for downforce generated by ground effect, $F_Z$, is roughly proportional to the inverse of the ride height squared, or $F_Z propto 1/h circumflex, $2. This means that even a tiny increase in ride height results in a massive exponential loss of grip. When you double the gap, you do not just lose half your downforce, you lose nearly 3/4 of it. By forcing the cars to sit 50 millimeters off the deck, the regulators had effectively severed the aerodynamic connection between the car and the track. For Mercedes-Benz, this mandate was a catastrophe. Their challenger, the new C-Class W202, was a rear-wheel drive platform. It relied heavily on mechanical grip and aerodynamic efficiency to stay planted. Across the pit lane sat their nemesis, the Alfa Romeo 155 V6 Ti. The Alfa was a technological marvel equipped with a sophisticated four-wheel drive system. When the ride height rule neutralized the aerodynamic grip, the Alfa Romeo could rely on its all-wheel drive traction to claw its way out of corners. The Mercedes, however, was left stranded. At 50 millimeters, the C-Class was operating in a zone of high turbulence. The airflow under the car was too chaotic to create a stable low-pressure zone, making the rear end of the car flighty and nervous at high speeds. The corporate headquarters in Stuttgart responded with what they knew best. They threw money and complexity at the problem. They developed an active ballast system, a mechanism that physically moved heavy lead weights inside the car from side to side to counter the G-forces in a corner. It was a marvel of engineering, but it was the wrong solution. It added weight and complexity to a car that was already struggling, and it failed to address the fundamental physics of the problem. The car was simply too high off the ground. The engineers were trying to force a bad aerodynamic setup to work through brute mechanical force. They were playing by the rules and losing. They needed a way to make the 50 millimeters disappear, and standard engineering was not going to get them there. The American spirit in Stuttgart. In the pristine, clinically lit halls of the Mercedes-Benz racing division, engineers are typically cut from a very specific cloth. They are the products of the Daimler-Benz apprenticeship system, a rigorous institution that values order, hierarchy, and absolute adherence to the process. In this world, the rulebook is treated with the same reverence as scripture, but Hans was a ghost in the machine. He was a rogue element within the skunk works who did not spend his evenings studying the company handbook or refining the efficiency of a valve train. Instead, he was obsessed with a very different kind of engineering philosophy, one that hailed from the humid, grease-stained garages of Daytona Beach, rather than the polite drawing rooms of Stuttgart. Hans was a student of the American South, and specifically a disciple of the high priest of rule-bending, Henry Smoky Unick. To understand the solution Hans was about to propose, you have to understand the man he idolized. Smoky Unick was a NASCAR legend who viewed the rulebook not as a set of laws, but as a challenge to his creativity. The story that captured Hans's imagination involved a particularly heated technical inspection at the Daytona 500. The officials, tired of Smoky's constant innovation, had compiled a list of 9 violations on his car. They were furious, and to ensure the vehicle would not be driven until it was fixed, they physically removed the fuel tank from the chassis. Smoky, completely unfazed, looked at the officials, hopped into the driver's seat, fired up the engine, and drove the car back to his garage without a fuel tank installed. As he pulled away, he yelled back at the stunned inspectors to add that to their list and make it 10 violations. That stunt was not magic. It was a masterclass in reading between the lines. Smoky had realized that the NASCAR rulebook strictly limited the size of the fuel tank to 22 gallons, but it said absolutely nothing about the fuel line. So, he installed a fuel line that was 2 inches in diameter and 11 feet long, winding its way through the chassis like a coiled serpent. That massive line held 5 gallons of gasoline all on its own. By the letter of the law, he was perfectly compliant. The tank was the correct size. He had simply found a place to store fuel that the regulations had forgotten to define. He wasn't cheating. He was operating in the silence of the regulations. This was the philosophy that Hans brought to the Mercedes C-Class crisis. He looked at the DTM regulations with Unick's eyes, searching for the silence. He read the mandate regarding the 50mm ride height over and over again until the loophole became blindingly obvious. The rulebook specified a static ride height. It described a car sitting motionless on the flat metal scales of the scrutineering bay. It said the car had to be 50mm off the ground when it was parked, heavy with fuel and sitting still. However, the rulebook did not say a single word about where the car had to be when it was traveling at racing speeds. Hans realized that the regulators had made the same mistake as the NASCAR officials from the 60s. They had defined the component, but they failed to define the condition. If he could design a suspension system that held the car up for the inspectors, but collapsed under the aerodynamic load of the racetrack, he wouldn't be breaking the rules. He would just be exploring the gray space that the regulators had left wide open. Hidden hydraulics and phantom grip. The core of Hans's innovation required a complete reimagining of how a race car is put together. In a standard 1994 C-Class DTM car, the rear subframe is a massive structural member that carries the differential and the suspension links. Conventionally, you bolt this subframe directly to the chassis with solid metal mounts. You want zero movement. You want the car to feel like a single block of granite so the driver can feel every pebble on the track. Hans looked at this rigid connection and saw an opportunity. He proposed a radical concept known as the floating rear subframe. Instead of bolting the subframe solid to the unibody, Hans isolated it. He used 4 bespoke mounting points that looked, to the naked eye, exactly like standard rubber isolation bushings. These were common parts you would find on a road-going Mercedes W124 taxi, designed to absorb potholes and reduce road noise. A tech inspector looking under the car would see these black rubber pucks and assume the team was just trying to dampen some vibration. But inside those innocent-looking rubber casings hid miniature, high-pressure hydraulic cylinders. These weren't shock absorbers. They were actuators capable of lifting the entire weight of the car's rear end. The brilliance of the system was not just in the lifting, but in the powering. Hans couldn't install an electric pump or a heavy battery pack to run these hydraulics. The extra weight would kill the lap time, and the whine of a motor would alert the officials instantly. He needed a power source that was already on the engine, silent and invisible. He found it in the power steering pump. The Mercedes 5.6 engine ran a high-pressure power steering circuit to help the driver wrestle the car through corners. Hans tapped a line into this circuit, bleeding off just enough pressure to inflate his subframe mounts. The final piece of the puzzle was the trigger. You cannot give a race car driver a secret button on the dashboard. In the heat of battle, they might forget to press it. Or worse, an in-car camera might catch them reaching for a switch that isn't marked. The system had to be automatic. Hans decided to use the engine itself as the switch. He integrated a calibrated bypass valve into the hydraulic line, tuned specifically to the pressure output of the steering pump at 3,000 revolutions per minute. At idle and low speeds, like when the car is rolling through the technical inspection bay or sitting on the scales, the engine spins below 3,000 revolutions per minute. The hydraulic pressure remains high, keeping the mounts fully inflated. The car sits tall, proud, and perfectly legal at the mandated 50mm ride height. But the moment the driver mashes the throttle and the tachometer sweeps past 3,000, the physics change instantly. This is the threshold where a race engine clears its throat and enters the power band. As the pump spins faster, the pressure spikes, hitting the relief setting on Hans's custom valve. The valve snaps open. The hydraulic fluid holding the car up is instantly vented into a low-pressure return line. Gravity and aerodynamics take over immediately. In less than half a second, about the time it takes to blink, the entire chassis of the Mercedes drops 40 millimeters. The car hunkers down over its wheels, sealing the gap to the asphalt and transforming the aerodynamics from a turbulent mess into a vacuum-sealed ground effect weapon. The neon blue fluid trick. This was where engineering stopped and industrial espionage began. Hans had a working hydraulic system, but he had nowhere to put the fluid. A DTM engine bay is a masterpiece of packaging where every cubic inch is accounted for. If he bolted a shiny new aluminum hydraulic reservoir to the firewall, the technical inspectors would spot it in seconds. They knew the anatomy of a C-class engine better than their own children. Hans needed a hiding spot that was already mandated by the rulebook. He found his answer in the most mundane component on the entire vehicle. The regulation stated that every car must have a functioning windshield washer system to clear oil and track grime from the glass. This meant every competitor carried a plastic tank of fluid right under the hood. Hans looked at that translucent plastic container and saw the perfect Trojan horse. He modified the standard Mercedes reservoir to serve as the high-pressure heart of his floating axle system. But this created a visual problem. High-performance hydraulic fluid is typically a golden amber or a dark red. Windshield washer fluid is universally recognized as neon blue. Hans solved this with a chemistry set. He sourced a specialized industrial dye and mixed it into his synthetic hydraulic oil until it turned a vibrant electric blue. To the naked eye, the liquid sloshing around in the tank looked exactly like the cheap detergent you would buy at a gas station. But the deception required one final layer of security. If an official asked the driver to test the washers and the nozzle sprayed hydraulic oil, the windshield would smear instantly, blinding the driver and failing the safety check. Hans installed a secret secondary bladder inside the main tank. This small flexible bag held about a cup of actual soapy water and was the only thing connected to the spray nozzles. It was a closed loop of truth hidden inside a tank of lies. An inspector could pop the hood and see the blue liquid. They could hit the switch and watch soapy water hit the glass. They would never suspect that the blue fluid they saw was actually powering a banned aerodynamic device, while the water on the windshield was coming from a hidden pocket no larger than a fist. Dawn at the Green Hell. In the pre-dawn gloom of late August 1994, the Nürburgring Nordschleife is a place of heavy silence. Hans and a skeleton crew of trusted mechanics pushed the Silver Ghost prototype onto the pit lane at exactly 5 a.m. They had to move fast. They needed to complete their run and get the car back into the transporter before the sun fully rose and the other manufacturers arrived for the day's industry pool testing. They were about to validate a theory that could change the championship, or get them all fired. The driver, a seasoned veteran who had spent the entire season wrestling with the unpredictable handling of the standard C-Class, was given simple instructions. He was to drive one lap with the hydraulic system locked in the static position, and then one hot lap with the trigger active. The first lap was a reminder of why they were there. As the car crested the jump at Flugplatz, it landed nervously, the suspension struggling to settle the tall chassis. Down into the compression of the Fuchs roar, the rear end threatened to snap sideways. It was the same fight the team had been losing all year, a car that felt like it was driving on tiptoes. Then came the second lap. As the car roared out of the pit lane, the tachometer needle swept past the 3,000 RPM mark. The bypass valve clicked open. Visually it was subtle, but dynamically it was violent. The entire body of the Mercedes dropped 40 millimeters. The air gap that had been plaguing the aerodynamics vanished. The car was no longer floating above the track. It was vacuum sealed to it. The data that came back to the pits was hard to believe. On the telemetry screens, the lateral acceleration figures spiked to 2.10 Gs in the corners, a massive jump from the standard 1.85 Gs the car usually managed. The Silver Ghost wasn't just gripping, it was carving. The driver found he could brake 15 meters later into the first turn. When they crossed the line, the stopwatch confirmed the impossible. The prototype was 2.5 seconds faster than the factory standard car. The skittish, nervous behavior was gone, replaced by rock-solid stability. When the driver climbed out of the cockpit, shaking his head in disbelief, he told the crew that the machine possessed an illegal level of grip. He meant it as a compliment, but he had unknowingly predicted exactly how the Mercedes board would view the innovation. A clash of cultures in Untertürkheim. Hans walked into the boardroom at the Mercedes-Benz headquarters in Untertürkheim feeling invincible. He had the telemetry data in his hand and a solution that cost less than a tank of gas. He laid it all out for the executive leadership. The 2.5-second advantage per lap, the elimination of the aerodynamic instability, and the sheer cost-effectiveness of the design. He explained that for approximately $50 in scavenged hydraulic fittings and a modified plastic tank, he had clawed back the performance deficit that millions of marks in traditional R&D had failed to find. He expected a promotion. He expected to be handed the keys to the racing division. Instead, the temperature in the room dropped to absolute zero. The executives did not see a brilliant engineering workaround. They saw a corporate death sentence. To the men who were responsible for the integrity of the S-Class and the global reputation of the three-pointed star, this device was not innovation. It was a scandal waiting to break. As Hans explained the details of the blue dye and the decoy water bladder, the mood shifted from curiosity to outright horror. One senior board member famously slammed the proposal shut and dismissed the entire project as a dirty American trick. In the hallowed halls of Stuttgart, this was the ultimate insult. It implied that the solution lacked engineering purity, that it was a crude hustle worthy of a demolition derby rather than the DTM. The board argued that the risk was simply too high. If the FIA inspectors ever discovered that the windshield washer fluid was actually high-pressure hydraulic oil powering an illegal active suspension, the fallout would be catastrophic. It would not just be a disqualification, it would be a public relations nightmare that would haunt the brand for a generation. Hans tried to stand his ground. He argued that he had followed the rulebook exactly as it was written. The regulations specified a static ride height, and his car complied perfectly when it was standing still. But his defense was brushed aside. The leadership made it clear that the Stuttgart way was about more than just winning. It was about winning with dignity. They decided that they would rather lose the championship to Alfa Romeo, honestly, than win it with a loophole that relied on deception. They viewed his interpretation of the rules as semantic gamesmanship that had no place in their company. In that moment, the gap between the engineer and the executive was wider than the gap under the car. Erased from the history books. The verdict from the boardroom was swift and absolute. There was no debate, no appeal process, and certainly no second chance. The project was terminated effective immediately. That very night, security personnel escorted Hans out of the Skunk Works facility he had called home. Inside the garage, the atmosphere was funereal. Mechanics who had just watched the car conquer the Nürburgring were ordered to undo their work. They tore out the neon blue hydraulic lines, yanked the modified washer reservoir, and removed the custom mounts. But the indignity did not end with disassembly. The chassis itself, the physical proof that the concept worked, was considered too dangerous to keep in storage. The following morning, the metal skeleton that had carried the future of suspension dynamics was loaded into a hydraulic crusher. In a matter of seconds, the Silver Ghost was reduced to a cube of scrap metal, indistinguishable from a wrecked taxi. Simultaneously, the technical drawings were fed into shredders, and the term floating axle became a forbidden phrase within the factory walls. The ultimate irony, however, arrived at the end of the season. The factory team, forced to return to the standard legal C-class, managed to claw their way to the championship anyway. Through the sheer driving brilliance of Klaus Ludwig and traditional aerodynamic tweaks, they won without the ghost. It made the destruction of Hans's masterpiece feel even more tragic. From outlaw to industry standard. The story of Hans and his impossible car did not end at the scrapyard. Disillusioned by the rigid hierarchy of the German automotive establishment, Hans packed his bags and left for the United States in late 1994. He found a new home with Team Penske and Ilmor Engineering, arriving at the exact moment Roger Penske was exploiting a massive loophole in the Indianapolis 500 rulebook to build the famous Beast engine. In the American racing scene, Hans was not viewed as a liability. His ability to read between the lines of a rulebook was seen as a survival skill. He spent the rest of his career in a world where creative engineering was celebrated, not punished. However, the ultimate vindication for Hans occurred 5 years later, back in the very boardroom that had exiled him. In 1999, Mercedes-Benz launched the W220 S-Class, a car that introduced a revolutionary suspension system called active body control. If you stripped away the marketing brochures and looked at the raw schematics, the irony was blinding. Active body control was a high-pressure hydraulic system that used actuators to continuously adjust the ride height and body roll of the vehicle. It was, mechanically speaking, the grandson of the Silver Ghost. The only difference was the trigger. Where Hans had used a mechanical bypass valve linked to engine speed, the new S-Class used sophisticated computers and accelerometers. The Mercedes board had rejected the technology as a dirty trick when it was used to gain grip in a corner, but they enthusiastically embraced it when it could be sold as the ultimate comfort feature for their flagship sedan. The cheat had become the standard. This saga illustrates a phenomenon often called the Germanic engineering paradox. When a governing body writes a rulebook with total precision, like the 50mm static ride height rule, they create a hard boundary. Brilliant engineers will always find the gray space that exists right at the microscopic edge of that boundary. The rejection of the Silver Ghost was never about whether the system worked. It was about whether it fit the company's self-image. But in the end, physics always wins. Today, every time a modern AMG lowers itself at highway speeds to reduce drag, or a GT car adjusts its rake for a high-speed corner, a piece of Hans's rogue engineering lives on. The car was crushed, but the idea was bulletproof.